Now, this investigation is going to start with a bit of a party, but it's a themed party because all of these things have got one thing in common. They all contain air. There's air inside the balloons and outside them too. There's air in this and this. Air in these crisp packets and lots of air inside this squirty cream. But this is no ordinary party venue. In fact, it's not a room at all. It's a chamber that can be completely sealed. This is a decompression chamber. The seals are all airtight, so you can actually control the amount of air inside the chamber. You can add or remove it through special valves. Help! Help! Oh, at last! Oh, thanks a lot, Shelley. Sorry, that is certainly not the place to be. Anyway, I forgive you. Come on, it's time for the experiment. It's time to add the air. As the air is added to the chamber, it gets more and more squashed, so it pushes harder and harder against the outside of the objects. The air pushes against the outside of the crisp packet. And it squashes the whipped cream. Right, and as if our party hasn't suffered enough, it's time to see what happens when we do the reverse. Take it away, Shelley. The air, that is. Now the air is being removed from the chamber through the valves. And look what's happening to our experiments. This time the balloons are getting bigger. There's less air in the chamber, so it's not pushing as hard as the air inside the banana. The air in the mousse expands, so does the air in the freshly whipped cream. And the exploding's finished. Oh my goodness. Well, this certainly goes to prove that air does push. And if it can do this to our big banana, imagine what it could do to us.
Yeah, no way would get me in there.
Yeah, you'd explode.
Or get squashed.
Imagine all the air pushing at you, squashing you.
Yes, but there's air all around us, isn't there?
Yes.
And it pushes all the time?
Yeah. Yeah.
So why can't you feel it pushing you now?
Smart question. You can't feel it because air always presses equally in all directions. It's called air pressure. Even though you can't feel it, ordinary air pressure is very powerful. Watch this. This may look like an ordinary bottle, but it's got holes in the bottom. But when the top is sealed, the air outside pushing up holds the water inside. As the candle burns, it uses up oxygen in the air. The egg seals the top, so no more air can get in. Soon, the candle uses up all the oxygen in the air. There's more air outside the bottle than inside, so it pushes the egg into the bottle. Pressure differences caused by burning can have much more serious effects.